So with this question, right, as mentioned already, it's more of a wildcard question. And it's also, in terms of what's like replicable, in terms of what you can repeat for similar questions, all you would need to look out for in these kinds of questions is, what have you been given? And how can you structure what you are supposed to work with so that it looks a little bit like this and also looks a little bit like that? Or rather, in your expression here, you want to at least work with the top, obviously, until it has something like this. Work with the bottom until it also has something like this. So let's work with the bottom first for now, or for lack of a. Okay, so the reason why I want to work with the bottom first is I just want to clarify something about that square root symbol there, because yeah, it's something that may not be very common. So if you look at what we have at the bottom here, you have square root of 5, right? And the whole thing is to the power of square root of p. So with what we are given though, here we're given 5 with square root of p equal to 64. So let's see what we can do to this so that at least maybe we have something like this explicitly. So what I'm trying to say is, if you're looking at what we have here, right? I mean, like, if you look at it nicely, the square root of 5 here is as good as having 5 to the power of a half, correct?
Yeah.
Yeah. Now, if you think of our exponential laws, the method to the madness here is we are trying to get to a point where we have 5 alone and then square root of p explicitly. So to do that, we can already see that here our exponential laws tell us that we can swap these, right?
Yes.
Yeah. So if you look, the moment we do that, we automatically have explicitly what we are given in our expression. You see, what they gave us here was 5 to the power of square root of p. And here we clearly have 5 to the power of square root of p. And then that's to the power of a half, which is fine. So automatically we know that this bottom part, right? We know it's this. We rewrote it like this, and then we rewrote it like this. Can you see we haven't done anything here? We have just written it in a different way.
Yeah, I can see that.
Yeah, and the reason for doing that is so that we can just have this explicitly, and we can change it to 64. And that's to the power of a half, you see?
Huh.
Yeah. And then we already know that the bottom is just 64 to the power of a half, of which you can put this in your calculator. You know, you can either put it as 64 to the power of a half, or you know it's just square root of 64, which we know I think is about 8. I hope, I think, I'm not sure. I think I think it's
8.
8. Yeah, it's 8. So we know that the bottom is just the 8. Perfect. So whatever we did for the bottom here, we're going to use somewhat the same analogy for the top. You see, for the top, we're going to try and restructure this until we can clearly see something that is 3 to the power of 9x. So for the top, right, let's put here top. So for the top, we can clearly see here we have 3 to the power of x minus 1, and then that whole thing is to the power of 3. So our exponential laws will tell us that it's 3, and this exponent has to be multiplied by 3. So we'll have that, you see.
Yeah.
Yeah. And the way we're doing it here, this is exactly what you can do for your answer sheet. You know, you can look at the bottom on its own, get a conclusion, look at the top on its own, get a conclusion, and then put it all together. So here now we can already see we're gonna get, we are going to get here 3 to the power of 3x minus 3. You see it, right?
Yes, yes.
Yeah. And then from there, our exponential laws can tell us that we are able to maybe split up we'll have at least 2 bases that have different exponents, because we already know that one way or the other, if you look at it nicely, right, one way or the other, here you can rewrite it as 3 to the power of 3x times 3 to the power of negative 3. And then from there, I mean, yeah, I think this is where things start to get a bit tricky, because the issue now is here we have 3 to the power of 9x, right? But then here we're only ending up with like 3 to the power of 3x, and we have 3 to the power of negative 3. So what you then do is, you see here at the bottom, because you cannot do anything here, you see, what you want to now work with is this original expression here, and try to get something that you also have here. So I'll repeat. What you have here, it cannot be directly linked to anything that you're given here. So what you can do is you can now take this that you're given up here, and you can now try and work until you have something that is either like this or either like that. So in terms of doing that, it's not necessarily a process, because here you can already see all we can do here is, I mean, like there's a 3x here there's a 9x. So automatically you already know that 3 to the power of 3 to the power of 9x, right? It can easily be written as 3 to the power of 3x, the whole thing to the power of 3, because 3 times 3 is the 9 over there. You see?
Yeah, I thought maybe it'd go that way. Yeah, I see it.
Yeah, because remember, I think this is where the whole scenario or the whole issue behind math being problem solving comes in, because we have seen a problem and we can see that the best way to solve it is to firstly work with this. Is instead of working with it as 3 to the power of 9x, we can work with it as 3 to the power of 3x to the power of 3, because now we can already see that, okay, fine, here we can isolate 3 to the power of 3x, because this 3 to the power of 3x, we want to at least link it to this. We want to be able to go from something that's here that we can throw here, just like what we had in the beginning. Here we had here whatever we had, but then the moment we had 5 to the power of square root of p, we could now take this 64 and throw it there directly. We want to do something similar. We want to take something from here directly and throw it where 3 to the power of 3x is. So here it's just a matter of isolating 3 to the power of 3x, meaning we can cube root the left like this, and then we can cube root the right as well. And then I think we should get, I don't know, maybe like 4. 4 times 4 is 16, times 4 is 64. So this number is a 4. And then here we have, this is going to cancel that 3. So here you have 3 to the power of 3x equal to 4. You see it?
Yeah, I see it.
Yeah.
But then
So
I
now
think I prefer that method.
yeah, so now at the bottom here, we can now carry on and say this 3 to the power of 3x, it's just a 4. And then here we'll have a number which you can put in your calculator. So in our calculator, this number is just going to be 4 over 27. And then, so for the top, for the bottom, you know, it's just an 8. For the top, it's just a 4 over 27. So you already know that from there, you can then just say, therefore, 4 over 27 is being divided by 8, of which in your calculator, you can just put that over there.
Yeah.
You see? So in your calculator, what does that come out as?
Give me a second, please. I'm hoping it comes out right. Let me just try that one more time.
Yeah, just put the fraction button and then.
Okay, no, I'm just confirming.
Okay, cool.
Okay, so yeah, it's 0,01. Well, 0,02 actually.
As a fraction, what is it?
As a fraction, it's 1 over 54.
1 over 54. Yeah, I think that one is better. 1 over 54. There we go. So that will be that for that specific question. Does that
No, that helps.
fantastic? Fantastic. So that's the big idea with this kind of a question. So what I can say about